So before we begin, we just want to note alpha and beta particles. Alpha particles are made up of 2 protons and 2 neutrons. Their atomic number is 2. Since the atomic number tells you the number of protons, it makes sense. The atomic number is 2. The mass number is 4. So the mass number tells you the number of protons plus the number of neutrons. And it just so happens an alpha particle is actually a helium atom. So at the bottom here we have the number 2, at the top we have the number 4, and we use the symbol He for helium. A beta particle is much smaller. It's only 1 electron. That means it can travel much further. It has less of a charge, and it's a smaller particle. Its atomic number, it has no protons, but it does have a -1 charge. So for our purposes, its atomic number is -1, and its mass number would be 0. There are no protons, there are no neutrons. So the symbol we use is 0 over -1. We use the letter E, a lowercase e. Okay, so you have boron decayed to form carbon and a mystery particle. The easiest way to do this is to look at the atomic numbers. So here 5 creates 6 and Z. So you're going to set up an equation, 5 equals 6 plus Z. 5 equals 6 plus Z. How do you solve for Z here? You subtract 6 from both sides. So 6 minus 6 is 0. On this side we're just left with Z. What is 5 minus 6? -1. Z equals -1. If our atomic number is -1, what is this? It's a beta particle, right? So we know that our mass number is 0, and we know that the X is actually an E. So our mystery particle is a beta particle. This is beta decay. Okay, so here we have actinium decaying to form francium and a mystery substance. If we just look at our atomic numbers, we have 89, 87, and Z. So 89 equals 87 plus Z. If you subtract 87 from both sides, you're going to be left with Z equals 2. Z equals 2. So in this case, your atomic number is 2. Your mass number is 4. So what does X equal? What element is this? Helium, right? And you can get that from the periodic table in case you forget. Is this alpha decay or beta decay? Alpha decay. Absolutely.
I got a question.
So in this example, nickel decays to form a mystery element and a beta particle. So right off the bat, what kind of decay is this? Alpha or beta decay? Beta decay. So we can answer that part immediately because of this beta particle here. This one right there. Now if we look at the atomic numbers again, we have 28, Z, and -1. So 28 equals Z plus -1. What do we do to get rid of this -1? You can add 1 to both sides, yeah. So 29 equals Z. Now what? Look at the periodic table. Which element has an atomic number 29? On this periodic table up here, they're in red.
Copper.
On the one in the back, it's the one at the top of the square.
Copper.
Copper. Okay. So, what is copper's mass number?
6.3.546.
Okay. So this is your mystery element. So nickel decayed to form copper and a beta particle. You have bismuth decays to form a mystery element and an alpha particle. So what kind of decay is this, alpha or beta? Alpha decay. Alpha decay. Now your atomic numbers again, follow them all the way through. 83, Z, and 2. 83 equals Z plus 2. Subtract 2 from both sides. You're left with 81 equals Z. Now what? Look at the periodic table, right? What has an atomic number of 81?
Yeah. I can't lose it.
Thallium?
Thallium,
There we go.
and it has 204.383 mass.
Okay. So the atomic number is 81, and our mass number here is going to be, in this case, it's going to be 208.
Sure.
Okay, so mystery element solved. So you need to copy down this table. It's going to be very, very important as you look at our half-lives problems. So what this table is saying is that after one half-life, you would have exactly 1/2 of your substance remaining undecayed. After 2 half-lives, you'd have 1/4. After 3, you'd have 1/8. After 4, you'd have 1/16. After 5, you'd have 1/32. You can ignore the 1/2 times 1/2 or 1/2 times 1/2 times 1/2 if that's confusing for you. But that just helps you see how we're getting the fraction of the undecayed amount. If that confuses you, you can just look at it as you're doubling the denominator every time. So from 1 half-life to 2 half-lives, you go from 2 to 4. From 2 to 3 half-lives, you go from 4 to 8. So in your first example problem, the half-life of iodine-131 is 8.1 days. How long will it take for 3/4 of a sample of iodine-131 to decay? If 3/4 of the sample has decayed, how much is left undecayed? If 3/4 is decayed, what do you have left?
1/4.
1/4, right?
Yes.
1/4 undecayed. Now, look at your handy dandy table you just copied down from that previous slide. How many half-lives go by if you have 1/4 undecayed? 1/4. 2 half-lives, right? So 2 half-lives, if you only want 1/4 of it still undecayed, that's 2 half-lives. The length of 1 half-life is 8.1 days. So if you multiply 8.1 by 2, 16.2. And this is in units of days. 16.2 days. Okay, the next problem, radon-222 is a radioactive gas with a half-life of 3.82 days. How long would it take for 15/16 of a sample of radon-222 to decay? So if 15/16 has decayed, what do you have left undecayed? 1/16. So, how many half-lives have gone by if you have 1/16 left undecayed? 4 half-lives, right? This is 4 half-lives. And again, I'm getting this 4 from the table that you did. Okay? I look at how much I need to have undecayed, and I get the number of half-lives from the table. So, 1 half-life is 3.82 days. You multiply that by 4. Let's see. What's 4 times 8?
32.
Okay, carry the 3. What's 4 times 3? 12 plus 3 more? 15. So this is in units of days. 15.28 days. Da-da-da. Number 3. Uranium-238 decays very slowly with a half-life of 4.47 billion years. What percentage of a sample of uranium-238 would remain after 13.4 billion years? So this problem is a little bit different. First of all, we're going to have to figure out how many half-lives went by in 13.4 billion years. So to do that, we look at 13.4, okay, our total amount of time, and we divide it by the length of one half-life. How are we doing on time? What? 4 minutes. Oh, we can do it. Number 4, a sample of strontium-90 is found to have decayed to 1/8 of its original amount after 87.3 years. What is the half-life of strontium-90? So here we're calculating the half-life. Our answer is going to be in units of years. If we have 1/8 undecayed, how many half-lives have gone by? So 3 half-lives. In a total of 87.3 years. So we need to divide 87.3 by 3. And that's going to give you 29.1. So your answer here is 29.1 years. So here's number 5, our last one. A sample of francium-212 will decay to 1/16 its original amount after 80 minutes. What is the half-life of francium-212? So after 1/16 is undecayed, that's 4 half-lives. 4 half-lives. So in 80 minutes, 4 half-lives have occurred. So you're just going to divide 80 by 4. And that's going to give you 20. So your answer is in units of minutes, remember. So 20 minutes is the answer.